Good morning. This is your stats sensei, Mr. Spensey, and we're going to do class work for the T distribution as our introduction to that distribution. So, a brochure inviting subscribers for a new diet program states that the participants are expected to lose 22 pounds. So, they're claiming a 22-pound weight loss in 5 weeks. Suppose that from the data, the 5-week weight loss of 56, so we have a sample size of 56, which I wrote down. And with the sample mean and standard deviation are found to be 23.5 and 10.2 respectively. So my sample mean is 23.5 and my sample standard deviation with an S is 10.2. What's the likelihood of getting a sample like this? Well, remember our T formula is T equals X bar minus mu S divided by the square root of N. And if I were to draw a picture of this, which I need to always do, we have 22 and is our claim. But we ended up getting a sample mean of 23.5, which is up here above it. So we're shading up. So we want the probability that T is greater than, when we start plugging in our values, 23.5 minus our claimed mean of 22 over standard deviation of 10.2 divided by the square root of 56. So let's go ahead and run that. Stat test, t-test. Highlight the word stats, and let's go ahead and input that information. Our claim was 22 pounds, but we had a sample mean of 23.5. We have a sample standard deviation of 10.2. We had a sample size of 56. Oops, got to go back. 56. And we shaded up and to the right, so this is a greater than. And we calculate, and we end up getting a T statistic of 1.1100. So the probability that T is greater than 1.1004 equals 0.1379. So almost 14%. All right, so that takes care of that one. Next one, a city health department wishes to determine if the mean bacteria count per volume of water at a lake beach is less than 200. So they want to know if the mean is less than 200. A researcher collected 10 water samples. So we have a sample size of 10 and found that the bacteria to be these values. They gave us a list of values. So we're going to have to treat this a little differently. You may assume that the measurements constitute a sample from a normal population. Does the data indicate the bacteria count is within safety letters? In other words, what's the chance of getting a sample like this given that their water is safe? All right, so here we go. So I went ahead and I input all that information, all this data into stat edit. Here, I'll press those buttons a little more slowly. So I press the stat button. All right, edit's highlighted and I press enter. And I go ahead and enter those values into the calculator. All right, so I've already done that. So I already have those values in. And it says, so once I do that, I'm going to go, well, stat, test, arrow over to t-test. And I need to highlight the word data. Actually, let's go back. Let's do something else real quickly. So let's go to second vars. Stat calc, not second vars, stat calc, 1 vars. My data list is L1, so second followed by the number 1. And let's write down what we have. We have an X bar equal to 194.8, which I've written down. We also have a sample mean, sample standard deviation. Make sure you choose the one with the S. is 13.1385. We had a sample size of 10, and that's the information that I needed. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 data points. Well, we need to write down our formula. P equals X bar minus mu S divided by the square root of N. We'll plug in just a moment, but let's go ahead and draw our picture. The claim is 200, and we ended up with 194.8. So 194.8, and that's my X bar. So let's plug in. So we want the probability that T is less than 194.8 minus the claim of 200, or at least that's what it needed to be. And remember, we always say that someone's innocent until we prove them guilty. So we're going to say it's less than 200 until we find out it isn't. And then we'll take the square root of 10. All right. So let's go back into this calculator. And we're going to go stat test. And we're going to select t-test. But we need to make sure data is highlighted because we put a list of data into the calculator. Our samples, the claim is 200. And then we need to make sure we put our list number. So second followed by the number 1. Make sure we have less than because they said less in the question. And they'll do our calculations for us. So the probability that T is less than negative 1.2515 equals a p-value of about 12%. All right, so there's about a 12% chance that you'd get that if it was 200. Now, one thing I want to point out to you on the calculator, when I ran it, it actually said, oh, there's 194.8. Well, that was the X bar, and this is 13.1385, and that was my sample standard deviation. So there's a couple different ways to get those values. The way I recommend, though, is to do stat calc 1 var stat. Stat calc 1 var stat. All right, number 3. A manufacturer asserts that the new collapsible bumper system, the mean body repair cost for the damage of an impact of 15 miles per hour does not exceed $400. To test the validity of the claim, 6 cars, so I have a sample size of 6, are crashed into the barrier at 15 miles an hour, and the repair costs are recorded. The mean and standard deviation are found to be 458 and 448. So X bar is 458, S is 48. You may assume the sample is taken from a normal population. What's the probability of getting a sample like this, given the claim of the manufacturer is true? All right, so our formula, T equals X bar minus mu S over the square root of N. Well, the claim is that it'll be less than $400. It's not supposed to be bigger than 400. However, we got a sample of 458. So that's bigger. But what's the probability of that happening if it really is just $400? So the probability that T is greater than 458 minus 400, because that's the claim, over standard deviation of 48 divided by 6. Because that's my sample size. So let's run that real quickly. Stat test. This time when we go to t-test, we need to make sure that stats is highlighted because we're inputting their data. And so the claim was it is $400. The X bar in this case is 458. The sample standard deviation is 48. The size is 6. And then we want to calculate. And so we get the probability of 2.9598. So the probability of t being greater than 2.9598 equals our p-value of 0.0157. That's a pretty small p-value. I'm thinking it's costing more than $400. All right, that's not quite 2%, but that's pretty small. All right, we're moving on to the next problem. Question 4. Industrial pollution often makes water supplies acidic, which is pH less than 7, or basic pH greater than 7. An industrial company claims that the mean pH level of the water at a nearby river is 7. So it's neutral. That's what it needs to be. As an environment, so you randomly select 19 water samples and measure the pH of each. The 6 sample mean possible water samples is normally distributed. What is the probability of getting a sample like this? So we have a sample mean of 6.9, a standard deviation of 0.24, and a sample size of 6. So probability, so our formula is T equals X bar minus mu, standard deviation of the sample divided by the square root of n. So we want to know to draw our picture first. And our picture says, hey, they're claiming it's 7, but we got a 6.9. What's the likelihood we get something like that? So we want the probability that T is less than 6.9 minus 7 over the standard deviation, which is 0.24, divided by the square root of 6, the sample size. T-test. Our claim is that it's neutral at 7, but we got a sample of 6.9. We had 6, our sample's standard deviation was 0.24, and we had a sample size of 6, and we shaded to the left. All right. So we get T equals 0.102. So the probability that T is less than negative 1.0206 equals 0.1771. And that makes sense that it'd be negative because we're on the left of the mean. All right, number 5. The manufacturer claims in their TV advertisement that the new design for a portable phone has an increased range of 150 feet. We don't even use those anymore. We use a cell phone, but allowing customers to use the phone throughout their homes and yards. So this is basically a cordless phone, which is before the cell phone. A consumer protection agency believes that its false advertisement suspects the range is less than 150 feet. So they're claiming 150 feet. They ask independent testing laboratory to test the manufacturer's claim and find a random sample of 44. So our sample size is 44, and worked over an average distance of 142 feet. So average distance of 142, that's my X bar, with a standard deviation of 12. So the standard deviation of my sample is 12. All right, so let's find out whether or not that claim seems reasonable. So once again, our formula, T equals X bar minus mu S divided by the square root of n. We draw our picture. Our picture is going to look like this. We're centered at the claim of 150. That's the claim mean. Well, we got a sample mean, and our sample mean was 142, which is less than what they said. So we need to plug in and see what happens. The probability that T is less than 142 minus 150 over 12 divided by the square root of 44. Stat test, T-test. The mean was claimed to be 150. Our sample size was 142. Our sample mean was 142. The sample standard deviation was 12. 12. And our sample size was 44 phones. When we go calculate, and we end up getting a very, very small number. So the probability that T is less than negative negative 4.4221 equals 0.0000, and I'm going to keep writing 327. All right, that's what that is. That's 4 decimal places. So whatever that number is, go one less, and that's 4. So I need 4 zeros. So there they are. That's approximately 0. I don't believe the manufacturer's claim. That's a p-value of 0. So battery manufacturer advertises that the mean reserve capacity of a certain battery is 1,500 hours. All right, so there's my claim. You suspect the battery is less than that, so we need a less than. To test this claim, you randomly select 50 batteries, so we have a sample size of 50, and find the mean to be 142.4 with a standard deviation of 320. Comment on the manufacturer's claim. So our formula, T equals X bar minus mu S divided by the square root of N. We draw a picture of this. Well, they're claiming 1,500. And we got a sample mean of 1424. This is my X bar. All right, so the probability that T is less than 1424 minus 1,500 over, what was our standard deviation? 320 divided by the square root of my sample size, which is 50. So what do we get when we plug that in? Stat test, t-test, and it's a t-test again, once again, because we're using the standard deviation of the sample. So 1,500. The X bar is 1424. The sample standard deviation is 320. That's what makes it a T. And we had a sample size of 50. We shaded less than. And the probability that T is less than negative 1.679 is about 0.0497. So the probability that T is less than negative 0.0497 equals 0.0497. Oops, I wrote that all wrong. That's wrong. This should be the probability that T is less than negative 1.6793 equals 0.0497. So at the 5% level, we'd say that that we would reject the claim, but that's not what they were asking us to do here. We just figured the probability of having that mean. All right, I appreciate you watching and hope to see you on the next one. Thank you.